Welcome, athletes, to 4.3, part 2, where we're talking about absolute extrema. So here in this case, we're not talking about all the peaks and valleys. We're talking about the highest or lowest point, right? And actually, it might not even be at a peak or valley. So this is the highest or lowest point. And so first of all, let's take a look at theorem 4.3, which says if we have a continuous function over a closed bounded interval. So remember, a closed interval is where we have included endpoints. All right, so that's a closed interval. The absolute maximum of f over I and the absolute minimum, so the absolute maximum and the absolute minimum, must occur at the endpoints or at the critical points, right? So basically what that's saying is if you have some kind of range from A to B, or some kind of interval from A to B, then a function's going to do it could do a few different things, right? I mean, there's really a lot of different things it could do, but if it's an increasing function on that interval, then the endpoint, the right endpoint is going to be the absolute highest point, right, on that interval. Or it could be a decreasing function, right? So it could go from A to B, and it could be a decreasing function on that interval, in which case the maximum would be the left endpoint and the minimum would be the right endpoint, and so forth, right? Or you could have a function, and we're talking about continuous functions, right? Or you could have a function that has some peaks and valleys, right? And it could have more than one, it could have one, whatever the case is, right? It could have some peaks and valleys in that interval, and then your absolute maximum would be one of the critical points, and your absolute minimum would be another one of the critical points, right? And so those are the basic scenarios that would happen is you either have some peaks and valleys in there, and your absolute max or min is at one of those peaks or valleys, or at one of the endpoints, that could be one of the highest or lowest points, right? And it could be a combination of those things where you have, you do have some peaks and valleys, but the endpoint is, or the endpoints still are higher or lower than the peaks or valley, right? Take, for example, like a cubic function, right? You have a couple peaks and valleys, but if you have an interval from here to here, even though you have some peaks and valleys in the middle, the actual highest point is one of the endpoints, and the actual lowest point is also one of the endpoints. So, all right. But remember that all this is saying is that your absolute maximum and minimum will either be at the endpoints or the critical points, right? There's no other point that you'd have a max or a min on a continuous function like that. All right. So this gives us a good strategy in order to find absolute extrema on a closed interval. First of all, we figure out f at the endpoints at A and B. So we find f of A and we find f of B, and we see what those values are. Then we find the critical points, and a lot of times we call those C, and then we evaluate f at those critical points, right? So we find f of C for any critical points C. All right, and then we just compare the values. So we see which is the highest of those points, which is the lowest of those points, and those are our absolute maximum and minimum values respectively. All right, so the largest of these values is the maximum, the absolute maximum, and the smallest of these values is the absolute minimum. All right, so that's what we'll do.